Ever since the discovery of Interstellar Object 3I/Atlas in early July, astronomers around the world have been working to interpret its unusual characteristics, trying to place it within the growing, but still extremely limited category of objects that arrive in our solar system from the deep, uncharted stretches of interstellar space. Classified as the third known interstellar visitor to enter our cosmic neighborhood, 3I/Atlas has naturally become the subject of intense scrutiny. Most astrophysicists agree that it is likely a comet based on numerous data points. Its behavior as it approaches the Sun, the gaseous emissions detected around it, and its general resemblance to icy bodies that typically originate in distant, cold regions far beyond the orbit of Neptune. Yet despite this consensus, Harvard astronomer Avi Loeb continues to raise eyebrows by emphasizing that something about 3I/Atlas refuses to sit comfortably within the usual categories. To him, the object's features hint at the possibility, however small, that it may not be entirely natural. Loeb's voice is influential not only because of his academic standing, but because he has long pushed scientists to consider unconventional explanations when data does not fully align with expectations. His skepticism toward the natural comet explanation stems from several lines of evidence. First, he argues that the object's trajectory is remarkably unusual even for an interstellar comet. Instead of following a path that can be neatly explained by gravitational interactions alone, its approach seems out of step with what scientists typically expect from icy bodies drifting between star systems. The fact that it passed remarkably close to Mars, allowing spacecraft around the red planet to capture fleeting images of it, only fueled Loeb's curiosity. To him, the proximity feels almost suspicious, as though the object were deliberately navigating through the inner solar system rather than randomly stumbling through it. Another feature that encourages his cautious speculation is the object's enormous estimated mass, believed to exceed 33 billion tons. This places 3I/Atlas at a scale far larger than either of the two interstellar objects previously detected, 2017's Oumuamua and 2019's 2I/Borisov. The idea that such a massive object could wander freely between star systems and then pass by ours raises numerous questions about the kind of processes in deep space that could create and eject something of this size. Loeb also argues that its chemical composition seems atypical. While comets are generally made of ice, dust, and volatile compounds, some preliminary analyses hint at a mixture that doesn't match the standard profiles. One of the most fascinating features is its so-called anti-tail, a phenomenon where dust appears to stream in the direction opposite of what would normally be expected, giving the object a geometrically backward appearance. Although anti-tails can occur through certain physical processes, Loeb notes that the angle and prominence of this one seem odd enough to warrant attention. In a recent Q&A on his personal blog, Loeb decided to quantify his hunch. Rather than couching his ideas solely in careful scientific language, he openly assigned a 30 to 40% likelihood that 3I/Atlas may not be entirely natural. He explained that this estimate includes scenarios where the object could be a piece of advanced technology, possibly even a dormant or disguised probe sent by an intelligent extraterrestrial civilization. He compared the situation to a Trojan horse, suggesting that it is not unreasonable to imagine a technological device camouflaged as a comet. Loeb has made similar arguments before, particularly with Oumuamua, whose peculiar acceleration and shape led him to propose an artificial origin. While many scientists disagree with his conclusions, he has consistently argued that dismissing such possibilities outright is unscientific, especially when anomalies remain unexplained. Despite his willingness to entertain extraordinary possibilities, Loeb acknowledges that the picture could change dramatically in the coming months. Several spacecraft are in advantageous positions to observe 3I/Atlas as it travels through the solar system. The European Space Agency's JUICE mission, originally built to study Jupiter's icy moons, is expected to make a relatively close pass by the object next month. Meanwhile, NASA's Juno spacecraft, currently orbiting Jupiter, will be near the object in March when it swings past the giant planet. Both spacecraft carry instruments capable of gathering detailed data, including optical images, infrared readings, and measurements of how sunlight affects the comet's surface and behavior. Because comets typically release gases and dust more intensely after rounding the sun, this phase of 3I/Atlas's journey is ideal for studying its material composition and internal structure. Loeb emphasizes that such observations could significantly refine or even overturn his probabilistic assessment. The way the object responds to solar radiation will offer key clues. If it behaves exactly like a traditional comet, sublimating predictable compounds, releasing material in ways consistent with known physics, and producing ordinary dust tails, it would strongly support the natural origin hypothesis. On the other hand, if it displays unusual acceleration, emits non-typical materials, or behaves in ways not accounted for by standard cometary models, the conversation may shift toward more exotic explanations. For Loeb, the important point is not to conclude prematurely, but to allow incoming data to shape theories rather than the other way around. Already, several glimpses of 3I/Atlas have been captured by spacecraft near Mars. NASA's Perseverance rover, parked on the planet's surface, managed to photograph the object as it streaked across the sky, a remarkable feat given the faintness and speed of the interstellar traveler. Meanwhile, the European Space Agency reported that both its ExoMars Trace Gas Orbiter and Mars Express spacecraft managed to snap images as well, despite the fact that 3I/Atlas was up to 100,000 times dimmer than typical targets. Such detections speak to both the sensitivity of modern technology and the rare opportunity provided by the object's proximity. Scientists at ESA expressed excitement not only about the data itself, but also about the improvisational nature of such observations. Spacecraft designed for entirely different missions were quickly and creatively repurposed to seize a fleeting scientific opportunity. Colin Wilson, ESA's project scientist for Mars Express and ExoMars, highlighted the thrill of witnessing these spacecraft respond to an unexpected event. He noted that although Mars missions routinely provide invaluable insights into the planet itself, capturing something as extraordinary as an interstellar object adds a dynamic and unpredictable dimension to space science. The images, once deeply analyzed, may reveal more about the comet's surface brightness, composition, rotation, and structural integrity. Even tiny details, such as how the coma spreads, how its brightness fluctuates, or how the anti-tail aligns relative to the sun, might offer important clues about its true nature. Yet Loeb warns that if 3I/Atlas is not a natural object, humanity may be startlingly unprepared for what such a discovery would imply. He notes that much of SETI, the search for extraterrestrial intelligence, has been designed around detecting radio signals or distant indicators of alien life. These hypothetical signals, originating from stars light years away, would not pose immediate risk, allowing researchers to take their time interpreting the data and forming protocols. But Loeb points out that an actual physical device within our solar system, especially one moving rapidly and potentially capable of altering its course, would represent a very different kind of scenario. Unlike distant radio emissions, a visitor in our cosmic backyard demands rapid attention and potentially even rapid response. He argues that humanity currently lacks clear protocols for such an event. There are no established guidelines for investigating, approaching, communicating with, or defending against an active extraterrestrial device. Loeb stresses that this absence of planning could prove dangerous if we were ever confronted with technology far superior to our own. If an alien probe were designed to gather data, to observe us silently, or even to test our defenses, our reaction time would be minimal. The lack of coordination between space agencies, governments, and scientific institutions might lead to confusion rather than calm, evidence-based action. He cautions that while the probability of such a scenario may still be low, the consequences of ignoring it entirely could be severe. Humanity has historically struggled to prepare for low-probability, high-impact events, pandemics, asteroid threats, and climate disasters being prime examples. In his view, the potential discovery of alien technology should be treated with similar seriousness. As 3I/Atlas continues its journey, the world waits for more data. eager to determine whether the object is simply a fascinating but natural traveler from another star system or something far more provocative. Loeb speculations, while controversial, have pushed the debate into territory that challenges conventional thinking. Whether his 30 to 40% estimate stands the test of incoming observations remains to be seen, but his willingness to question assumptions ensures that the scientific community remains alert to every possibility. In the coming months, as spacecraft collect unprecedented close-range data and astronomers refine their models, our understanding of this mysterious object will almost certainly evolve. Until then, 3I/Atlas remains a compelling reminder of how vast the universe is and how little we truly understand about what drifts through it.